So, hi class. So, welcome to another lecture on the C programming. So, today we will be seeing what are scope variables, right? So, how do we define scope and what is the scope of a variable? So, a very easy topic, just some basic rules that you need to remember in this class. And this is the last lecture before the midterms arrive, so in the next week. So, we will have all the syllabus that we covered till today, right? So, we have functions, pass by reference, pass by value, and the scope, along with what Dr. Saurabh had taught, right? So, let us see the first lecture today. So, first lecture basically we will see what are local variables and what are global variables, right? So first we will just see what are local variables. So in this code you can see I have three variables a, b, c, right? They are 10, 20 and 0, and I'm just printing the value of a, b, and I'm doing c as sum of a and b, and then for the sum I am calling a function and then returning the value in C, and then finally I'm printing C. Obviously it will be 10 plus 20. Let us just see the output here, right? So value of A and B in main is 10 and 20. Value of A and B in sum is 10 and 20. Why? Because 10 and 20 are passed here. 10 gets copied to X, 20 gets copied to Y. We do the sum of both the values and then return the value of P. P returns basically to the value C, and C is 30, right? So when I say what do I mean by local variables, the meaning of local variables is, for example, you have an integer A here, right? Where is the integer declared? Integer A is declared in the main, right? So technically just see it like this. The validity of integers A, B and C, the validity of integers A, B and C only exist in the main, right? So where is the main starting? Main starts at line number 9, ends at line number 24. So validity of A, B and C is only between the lines A, B and C, which is basically between the lines 9 and 24. Now what do I mean by that? So let's say you are passing A and B to the function, right? So beyond 24, A and B and C does not exist, right? So let me just show you one example. It will pop an error. Just see this. Let me try to print the value of ABC as ABC. A, B, C, right? So when I try to run the code, right, you can see this A undeclared, B undeclared, there is an error, C undeclared, right? Now why it is saying undeclared? We has anyone declared A, B, and C in the main function? Now this thing basically is known as the scope. Scope means basically where is the identity of the variable now existing. So in this case, you see ABC basically has an identity from in the main, and which lies from line to line number 24. Similarly, what happens if I try to print the value of X and Y? See, and X and Y are defined here. So X and Y have a validity from line number 27 to line number 39. Beyond this, X and Y don't exist. So let me try to print these values in the main. It will again give an error. You can see X undeclared, Y undeclared, right? So now what is the importance of this and why do you actually need it? See, this is required because whenever you are passing variables by value or by addresses, you need to understand where would the life of that particular variable be there, whether it will actually be accessible or not accessible, right? So for example, in this function, accidentally you are trying to use the value of A thinking that you have defined A in the main, then it will result into an error, right? Now what is the easy method to see what is the scope of the variable? So let us return back to our drawing board, right? Now the code is executing correctly. So what we had integer of main A equal to 10, B is equal to 20, C is equal to 0. And what happens? We are calling sum with A and B, and we have integer sum. I'm just writing a shorthand. P is equal to x plus y and return P. Right? I'm just writing in a shorthand. So now what happens here? Let me change the pen color. So you already saw that ABC, when I try to access it here, it is not allowing us. Similarly, X and Y. So X and Y, when I try to access here, it is not allowing, right? So now how do you remember that, okay, what is the scope of the variable? A very easy way to do that is just to see, class, just a second. Easy method is to just see the braces that are preceding it. So what do I mean by braces? So for example, you have A, B and C. So start with A, right, and just go upstairs, right, and locate the first curly bracket. So when you go up, and what is the first curly bracket? It is the bracket of main, right? So when you see here, what is the first curly bracket going upstairs? It is line number 9. It is the first curly bracket. And to just check till what point it exists, now just go down and check the last curly bracket. Basically the first closing curly bracket. This should be first opening and first closing. So when I go down, this is the first closing curly bracket. So basically the scope of A, the validity of A will be from this point to this particular point, right? For functions, just assume that whenever I'm defining integer x and integer y, assume that this is the first line of the function. So x and y will exist till the last curly bracket, and basically the opening curly bracket means x and y can be accessed in this particular part only, right? So that easy it is to check the scope. For example, when I see for B, I will go up, locate the first opening bracket. I will go down till line number 24. This is the first closing bracket, right? So the scope of A, B and C, if you can see, is from line number 9 to line number 24. So that means up till line number 24, whenever I will print the values of A, B and C, I will get correct values. They will not be set as undeclared. Similarly, for X and Y and P, from line number 27 to 34, I can get the correct values. Outside of this, it will show undeclared. Fine. So now let us see another example. Okay, so this is a very simple example. Probably I just tried to show few things here. So here what happens, this basically what happens, there is something called as local variable declaration. So in the next program, you will see what is a global variable, right? And hence just keep in mind the term local, right? So when I say local, local means if you see in this case, A, B and C have a validity from line number 6. As I said, go upstairs, locate the first opening curly bracket, go downstairs, locate the last curly bracket. So you can see A, B, C are basically local to main. I cannot access A, B, C outside of main, right? Hence they are called local variables. Why local? Because it does not have a validity outside the main, right? It's just like for your Aadhaar card. Your Aadhaar card is like a local stuff which is only applicable in India. Beyond India, it is no longer applicable, right? It has no validity. Same thing goes here. A, B, C have validity only in the main and not beyond the main. Fine. So this is done. You will actually understand when I say local here in the next program, when I say what is a global stuff, you will understand what do I mean by local and what do I mean by global, right? So now in this case, if you see integer a and b, how we are seeing global variables here. These are still local variables. I'm writing local variable declaration. You can see integer a comma b. You go up, up, up. Line number 10 is the first opening bracket. You go down, and line number 29 is the first closing bracket for a and b, right? So basically the validity of a and b is only from line number 10 to line number 29. So previous to line number 10, A is not defined, B is not defined. After line number 29, A is not defined, B is not defined, right? As we already saw in the examples of pass by value, you can see this is pass by value. The value of A and B gets copied to a separate memory location. So this A and this B are basically different. This A and this B are basically different. And now let us see, here comes the global variable g, right? I am writing g is equal to a plus b. And now you can see where I have defined g, right? You can see I am defining it outside the main, right? I am defining g outside the main, and in fact outside all the functions. I am not defining g in void sum. I am not defining g in the subtract function, right? So sub ab. I think this would have been better with x and y, so that you could have understood it well. X, y, x, y. So this is x, right? Now keep in mind one thing, integer g, right? It is defined outside the main and even not within any function. So what will be the scope or access of g? So access of g here, g basically is a global variable declaration. Now why do I say it global? Because see, we had a formula that wherever the variable is declared, you go up, up and locate the first curly bracket, right? So from g, when I go upstairs, I don't see any curly bracket, right? I don't see any curly bracket. So it is existing from here till line number 1, right? And then for g, because there is no opening curly bracket, we cannot define a closing curly bracket, right? So in mathematics, when we don't write something like 5 plus 3. If you write something on your scientific calculator, it will give an error, right? The parentheses don't match. Now since integer g does not have any, basically it is not a part of any function. See, we also know main is a function, sum is a function, and subtract is a function. So how to identify a global variable? Global variables are declared outside all the functions, including main. Global variables are declared outside the functions, outside all functions, including main, right? So you can see g is outside the main. So you can see in the main function, I'm not writing integer g because g is already defined. And now you can see even if g is outside the main, right? If you remember in the first example, I was not able to access a and b and c inside the function. Remember? If I write here a, it will give an error. If I write here a, you can see a is undeclared. Why a is undeclared? Because a is defined locally to the main function, right? I am declaring a in the main function, not outside the main. Fine. Now in case of global variable, what happens? You declare g outside all the functions. So this g is applicable in all the functions. This g is applicable. So now you can see when I'm doing g equal to a plus b, it is giving me 10 plus 20, which will be 30. So you can see value of a, b and g. So first the subtract function is called and I'm passing 10, 20. So now you can see in the subtract function, I'm calling a and b as 10 and 20. They get copied into x and y by pass by value. And now what I'm seeing a g is equal to x comma y. So this is 10 minus 20. But see, we have not defined g in the function, whether it's an integer or float or anything. As against, if you see in the first example, when we wrote p equal to x plus y, we are defining in the function that p is of type integer. But if you note here, in this I am not defining that G is of type integer. Why? Because you can see integer G global variable declaration. It is a global variable declaration because it is declared outside all the functions. So I just can use that value to get the subtraction. So this is 10 minus 20 is minus 10. I return back to the point where it was called sum equal to AB 10 comma 20. So 10 plus 20, which is 30. Both the functions are called, and now value of A is equal to, see, A was 10 in the function, B is 20 in the function, and now I'm printing the value of G. Now you can see G has taken the value 30, right? Because when we call the subtract function, G was having a value minus 10. You can see G was having a value minus 10. Then we returned back, then we called the sum function. Now G was having a value 30. Now it came to main. Now again I'm printing the value of G. So instead of minus 10, G is taking a value 30, right? And now I will tell you, so what is the memory location mapping for a global variable? Let me just go to the previous slide, pen color. So now what happens when you have the main integer, let's say A is 10, B is 20, right? So you are calling a sum function, you are calling a subtract function. Okay, we are calling the subtract first and the sum later on. Okay, this is done. So now you have a subtract function where you are saying G is equal to A minus B. I'm just writing in shorthand, and this is equal to sum A comma B. G is equal to A plus B. And how do you define a global variable? You declare the variable G outside all the functions, integer G. Now let us see how does the memory location actually allocate this, right? So you have a main function, you have a subtract function, and you have a sum function. So what happens here? So let me have pen color black. So in the main function, we are defining A and B, right? So main function. So what will happen? A will have a separate memory location, B will have a separate memory location. It will have 10 and 20, right? Similarly, the subtract function will have its own memory mapping. Even if we call it with A and B, this will have A and B. If you remember the example on swap, things were getting copied and then the swap was happening on the copied case because the memory location was arranged like this. And then we have a sum which again has A and B as 10 and 20. So you can see even if we have AB, AB, AB in all the cases, they have a separate memory location. So total, if every integer takes 4 bytes, so this will be 4 plus 4 plus 4 plus 4 plus 4 plus 4, right? 24 bytes. And now since this guy is our global guy, for this only one copy will exist. Only one copy means G will have some value and main will also use this value, sub will also use this value, and sum will also use this value. So now you realize when you actually call sub from the main, when you actually call this function from the main, what happens? 10 minus 20, global becomes minus 10, right? So you can say this becomes minus 10. And now I return to the main where I'm calling sum equal to A plus B. So G is equal to A plus B. Because G is a global, it can be accessed in all the functions. Since G is global, it can be accessed in all the functions. So now what happens? 10 plus 20. So what happens? This value minus 10 will be overwritten because they share the memory access. There is only one location. So now 10 plus 20 will become 30, right? So now if you do another operation, right? So let's say I am again calling the subtract function, right? So now if you will see that global value of g is again minus 10. Why? Because you are calling the subtract function. So this will cancel out and this will become minus 10, right? So this is the important message that I wanted to show here, that global variables are accessed by all the functions including main, and it has only one copy in the memory. So whatever you overwrite, it will get overwritten, right? So it will have only one value. So class, let us have a break for 5 minutes. It is 12:23. So let us return at 12:28. I'm just pausing the recording. Hi class. So back to the lectures. Prakhar, for the midsem, it will have only MCQs, no theory questions. You will have a set of multiple choice questions with negative markings, and mostly the programs would be predict the output only of those kind. You will be given a block of code and you will be asked to predict the output or put some suitable, like in a 10-line program, one line will be blank, and we will say that okay, the output of the program is this. So write what will be in the blank line, right? So don't worry, there will be no theory questions where you have to write. There will be no answer sheets also. You will have to solve it on the question paper itself. Right? So now we are back to global. So as always, global is can be accessible everywhere. But remember one thing, it is always a good practice never to use global, right? It is a good practice to never use global, because keeping a track what is the current value of global is very difficult, right? As you can see, all the functions and all these things change the value and write on the single memory location. You can never trust the value of global, right? And the bad part is you can actually initialize also global anywhere in the code, right? So for example, I'm doing subtraction, sum and subtraction. Now I can write g is equal to 0. So now you can see the value of g becomes 0, right? So it's very bad practice to use global, but okay, from a knowledge point of view, we should always know okay, something of this sort exists, right? So now let us see again the program. Again here, g is a global variable because it is declared outside the main, right? Let me just run the code. So now you'll see one thing is here. Now you can see I'm defining integer g as 20 as a global variable. And now in the main function, I am again declaring g as 10, right? So what happens if you see this global variable has accessible across, right? The validity is everywhere. And now again I'm declaring g in the main, right? So this g will have a validity from, you can go up to this curly brace and this curly brace. So this g has a value which is applicable only from line number 9 to line number 20, right? So in this case, when we basically have the value of g, the output basically comes as 10. Now you will say why not 20? So this is basically the syntax of C, right? Syntax means basically it's a rule in C that whenever you have the same variable name, right? So let us come back to the drawing board. G is 20. You have main. So printf G, right? So now if you see this global variable has an access from this point to this point, global G. And if I ask you the access for this is, for this G, it is this much, local G, right? So if I draw in terms of set theory, This is the local G validity, right? So let me just shade it with black. And here it is the global G validity. So you can see there is an area of intersection here. This is the common area. So at this point, what does the compiler say is that if I have two variables, which is local as well as global, I will prefer the local one, right? So the local one is always preferred, right? Something like now we are seeing country of origin on Amazon products and all. So we try to prefer like make in India products and all those things. So whenever you have a global and a local variable having the same variable name, so in this case it is G and G, the local is preferred, right? As against this, now let's say if we have a function here, right? Function is just like, let's say PR, and you are printing the value of G. So now you know this local G has only the scope till here. So in this function, automatically the global value will be picked, right? The global value will be picked, right? So in case of local and global variable, the preference will be given to the local variable, right? Now there is one more program. We have a new keyword here. I will explain you. So there are some doubts. Yeah, Shiva, you are right. It means we can get the value of calculated by a function without returning. Yeah, in case you are using a global variable, then you need not return anything from the function. You can just define a global variable and just access that value. Predicting output will also be MCQ. Yes, it will be MCQ only. So now you can see here what I'm doing. Integer x is 50, which is a global variable. I just clear the screens here. And again, I'm defining x is equal to 10, right? So now if you can see here, x is equal to 10 and here x equal to 50. So what I will do, I will prefer the value x equal to 10. So now you can see value of x local is what it will come? It will come as 10. Okay, and value of local variable x is x. I don't know why it is g here, x and x, right? Now what I'm doing in the main also, I am defining a set of curly braces and I am saying extern int x. So extern basically means external, right? So now see what happens in the previous case was I am having an integer g equal to 10 and when I print the value of g, I get the value as 10. I get the value as 10, right? Now what if I wanted to actually print this value? I wanted that, okay, for some particular case, I want to print the global variable and not the local. See, by default, the compiler is using the local variable. In that case, what you do is like you define extern int x. So what do I mean by extern? Just check the output for this code. You can see x is 50 as a global variable and x is equal to 10 in the local variable. Fine. So now what happens is we have integer x is equal to 10. So value of local x is 10 that we already seen in the previous case. Address is percentage x, so it will have something 6422300 local variable and value of global. Address is here. So let me guys just press use a slash n so that things and the output are clear. Right. So now you can see value of local x is 10 definitely. Then address of local x is 6422300. And now when I say extern int x, so when I say extern int x, it tells the compiler that even if you have defined x as local, and if x is having a global value, prefer the global one. Prefer the global one, right? So extern says extern as such means external. So if you have x as a local definition, which we have, in that case, prefer the external value. So what do I mean by external value? I mean the global value, right? So now let us see what happens in this case. So value of local is 10, value of this is this. Now value of global x is 50. So you can see, even if I'm writing x here and printing the value of x, because x is now an external value, right? Now again remember, external integer x, right? For this x, what is the scope? Go up, first opening curly bracket, go down, first curly bracket. So this scope is only till this particular limit. This scope is only till this particular limit. Got the point? So it is printing the address of the, this basically will be global variable. Now since extern int x has a validity from here to here, again when I'm printing the value of x, it will print the value 10 only. Why? Because this external variable had a validity only from, had the scope, actually in technical terms, had the scope from 15 to 19, right? So this is how from the main function you can also access the global variables. By default, it will give preference to the local variables. Again, I'm telling you that please avoid the usage of global variables. It is good for MCQs and knowledge and everything, but in theory, in practical, you need to avoid it, right? Again, so we are seeing some more example of the scopes. Here we have integer x equal to 10, y equal to 20. So how do you know what is the scope of this? Go up, start at the opening curly bracket. Now what is the matching closing bracket for this? The matching closing bracket is 28, right? So the variable x equal to 10, y is equal to 20 will exist from line number 8 to line number 28. Beyond this, it won't exist. Now what happens here? In this case, I am having printing the value of x and y here. So let us see what it comes out. So initially it is coming x equal to 10 and y is equal to 20, which is okay, right? Because it, this x and y has a validity till this line. So x is 10, y is 20. Now y is declared again, so the outer block of y is not accessible, right? What do I mean by this? Now again I am redeclaring y as 40, right? I am declaring y as 40. So what is the existence of this y, or the scope of y? Go up, opening curly bracket, match with the closing bracket. So now you can see this y equal to 40 has the scope from line number 14 to line number 23. And now when you can see here, I have y equal to 40 and y equal to 20, but this scope is more local than this one, right? It is more recently defined. So the compiler will not take y equal to 20, it will take y is equal to 40. So when I do x plus plus, right, it will take x plus plus means 10 plus plus, which is 11. But when I do y plus plus, right, so integer y is 40 and y is 20, right? So it will give more preference to the value which is recently defined, right? And it happens normally also, right? So if you say integer a equal to 8 and then you say a equal to 9, so the compiler will compute all on these values, right? But in this case, what I'm having integer y is equal to 40. The access of this y is only from this point to this point. So when I'm doing y plus plus, that means 40 plus plus, it will give me the output as 41. So you can see x is 11 and y is 41. The moment you exit this particular bracket, so that means integer y is equal to 40 now will no longer exist, because these braces are now over. Now when you print the value of x and you print the value of y, you actually get 11 and 20. Why? Because x was already 11 and y, which was 41, now is now invalid because this loop is over, this brace is over. So what was the original value of y? That was 20, and it is having a scope till this particular line. So I print the value of y as 20, right? So I hope you get this. A very easy concept. You just see from which point integer y is equal to 40, go up, opening curly bracket, match the closing curly bracket. This y equal to 40 only exists from this to this. Any printf beyond this line will have a y which is existing beyond this. So this y will actually print the value of this y is equal to 20, right? And now if you see, integer x and y are declared from line number 9 to line number 29. So if I print the value of x and y here, it will actually say x and y undeclared. It should say that. You can see x is undeclared, y is undeclared. Why? Because this x, you go upstairs, line number 9, closing bracket, line number 29. That x and y only exists from line number 9 to 29, right? Not beyond that. So I'm deleting this line. Again, this was a simpler example. So what I'm doing here, I'm defining integer x as 10, opening bracket, matching closing bracket. So this x exists from line number 8 to line number 10. Now what I'm doing, I'm having a curly brace and I'm printing the value of x. You see, it will show an error saying x undeclared. Why x is undeclared? Because scope existed from 8 to 10 and you are printing in line number 12. How to clear this error? I can just remove this. Now x exists from line number 8 to line number 12 and the print is on line number 11. So all good. The value is printed. So small things, and it has a huge implications on the code. Right, again x equal to 1, y equal to 2, z equal to 3. So I am printing the value of x, y, z. So from line number 8, if you go upstairs, it is the phi line number which has an opening curly brace, and then it has line number 20. So x, y, and z exist in all of the program. Now what I am doing, I am opening a curly brace, I am writing integer x is 10, y is a float of 20. So where it will exist, from line number 10 to line number 18, right? Now I'm defining integer z. So what I'm printing, x, y, and z. You can see I'm only defining x and y here. So you see x and y change from 1 to 10, 2 to 20. But since I'm not redefining z, z remains as 3. So z is 3. Now within this loop, what I'm doing here, I'm defining integer z as 100. Validity, go up, opening bracket, matching closing bracket, 14 to 17. Z equal to 100. So now you can see 10, 20, and z is equal to 100. And now let us print this line once again before the return statement. So now you can see x changed twice to 10, but x equal to 10 only existed between this line to this line, 10 to 18, right? Opening bracket, closing bracket, this one. So beyond this, x did not have a value of 10, so it used up. Okay, do I have another value of x? Yes, I have a value 1, y is equal to 2, and z equal to 3. Even y existed from this point to this point, right? So scope is not difficult. What if there is no local? The global, yeah, if there is no global, obviously the local will be considered, just like you are doing your CS112 codes, right? Prakhar, like we have declared a variable without any function, we can also print any statement without any function. I didn't get Prakhar. Okay, last but a very beautiful thing is static, right? So let me just check this whether I have integer function. This is static count plus plus. Okay, class, this is a very interesting program. If we simply write x equal to 10, the global. Okay, so class, just see this function, and this has a very nice output. So we will see, like in the previous case, you use the extern, right? You use the extern thing. So what was extern doing? Extern basically was printing the global variable inside a local function, right? And now what is the use of static? Now just see, it's a very small function named fun. And what I'm doing, I am defining count is equal to 0, and I do a count plus plus. So 0 will become 1, and then I return the value of count. So what I am returning, I am basically returning 1. I return here Again I call the function, again I call the function, right? So, and let me do one thing. And I'm printing the value of count, right? Oh, I think it is some wrong output because it should print 5 times. Oh, this is because of system clear, right? 1 1 1 1 1 1 1. Why? Because once I'm printing in the main and once I'm printing it in the function. So let me just write here system CLS. Okay, so you get the point. Function. Now let me just write this in function. So in function and in main, in function and in main, right? So basically all these lines are. So let me print here also. In function one, in main one, right? So why happens? Because we are calling the function. We define count is equal to 0, count plus plus. So count become 1. I print the value 1 and return 1. So when again the function is called, this initialization is again 0. So again 0 plus 1. So this operation continues. So what if you want that this count should be retained? So when you are calling it 5 times, the value of the count should come to 5. So for that, C defines a access specifier which is known as static, right? So the moment I write static int count, the moment I write static int count, basically what the compiler does is like it retains the value. It retains the value between function calls. Now what do I mean by that? You just see this, right? So now you can see it is 1 2 3 4 and 5. Why? Because I use the static keyword. So without static, what it will be? It is, oh, I didn't save the code. Without static, it is 1 1 1 1 1, because the value of count. Now you can see count has a scope from line number 5 to line number 11. Count as this scope. The moment I exit the function return to the main, the value of count does not exist. The value of count does not exist. So again, when I call the function, it starts from 0, right? And hence the output is 1 1 1 1 1 1 1. The moment I define static, it now means it tells the compiler that, okay, I will be exiting the function, but please maintain my values between the function calls, right? So now you get the output as 1 2 3 4 5. Simple point to remember, static will retain the values between function calls. That's it, right? So let me just see the output of this code also. Okay, so this is A and static. S plus A is 3. Ignores declaration. So 10 plus 5 is 15. Okay. Okay, fine. So here is a main function. I'm defining integer I and I'm calling the FOO function 10 times, right? I'm calling it 10 times. So now what happens here? It comes to the void foo function. I have a variable A, right? And I have a static int SA, right? So now you can see I'm doing an increment of A by 5. So A will become 15 and I'm printing the value and the address, right? And now in this case, you will see that eventually this will be called 10 times. Now since A is a normal int, it will always be initialized to A. So it will always become 10, 15, 10, 15, 10, 15, 10, 15. So I think this system should have been here. Exactly. So now you see one important thing here is that I am defining one normal variable and one static variable. Fine. So every time the function is called, this will be called 10 times, right? So every 10 times A is initialized to 10 and A will come as 15. Why? Because it's a normal int. The scope of A is from line number 5 to 16. The function exits, the value is lost. But static is to preserve the value. It has a value 10. So now you can see initially A becomes 15, SA becomes 13, right? Because 10 plus 3 is 13. And now you can just keep a watch on the address, right? Uh, Technically the address is same because of compiler optimization, but you just see the value. A always remains as 15, but since I'm declaring SA, static A, as 10, this basically keeps on incrementing because SA I'm incrementing by 3. So 10 becomes 13, 16, 19, 22, 25, and so on. So here you can see a live example that a normal int is always reinitialized because normal int basically prints 10 and then 10 plus 5, 15, and it is always 15. But static int basically keeps on incrementing up to 40 because the loop was called 10 times, right? And the increment is 3. So 10 into 3, 30. What was the initial value? 10. So 10 plus 30, which is 40, right? So guys, I think that's it for today. This will be the last portion till the midsem. So, so we can say static makes variable to act like global. Yes, you can say it. It is like a global, but only global to one function in which it is defined. Right? It is kind of global to only one function. So static is still far more better than global because you cannot access static variables outside the function, right? It is only restricted to that function itself. So okay guys, I am exiting. If you have any doubts or else all the best for midsems. It will be an MCQ based paper only, right? And don't worry about theory questions. We will not ask something like, okay, write a short note on for loop. No such questions will come. There will be no answer sheets. We will just give one rough sheet, but you need to predict the output and all. Fine. So have a good day.